Alright, so when we left off, we were deciding whether or not we needed to make these changes and we needed to send in signals instead of actually sending in these starts. So right here, instead of pump equals 1, that's going to be pump underscore start equals 1. And instead of this being pump equals 0, this is going to be pump underscore stop equals 1. Same thing here. This is going to be heater underscore start. So let's just punch that in right there. And then we also have to add an underscore stop on this one right there, and that's also going to be a 1. So now that we're controlling them there, we also need to go ahead and control these reflexively. So let's come over here, and if we're telling our pump to start and making that 1, then let's go ahead and make stop equal to 0, just in case it isn't already. And the same thing here, we're looking at setting stop equal to 1. So let's go ahead and hit set start equal to 0. And we'll do that up here as well. So same deal, stop is now going to be equal to 0 if we're trying to turn the thing on, and start will be equal to 0 if we're trying to turn the heater off. Okay, so that kind of makes sense right there, right? Now, we've got these things coming on, going off, and then we're same thing with our mixer. So mixer start is going to equal 1. Mixer stop is going to equal 0. Rather, mixer stop is actually going to equal 1. And then let's copy and paste these appropriately and disable the starts and stops where we need to. And we are done. So just like that, now we're at least controlling all of our loops. So we're going to be able to get this thing up to temperature. We're going to be able to get it up to level, keep it where we want it, and then now we just need to start working out the transition logic to get out of here. So remind me, what was the transition called? When we're going into operation, we want to energize operate signal. But remember, we're also going to have to create logic to control alarm signal 1 and this offline signal 1. So we need to control all of that from within this logic. So let's go ahead and start looking at our operate signal, and I'm just going to copy that so I've got it. And what do I need to look at for operate signal? Well, I need to look at my temperature being good, and actually my mixer is going to tell me whether or not my temperature is good. So I need to look at the mixer, and then I also need to look at my level. And based on those, I need to set a timer because the mixer needs to be running for 30 seconds. And once that's all true, then I can go ahead and tear out and I can go to my operation. So when do I want to set this? Well, I'm just going to go ahead and bring it in here now. So operate signal colon equals 1 semicolon. So I'm now energizing this, but I'm also going to de-energize that at the very beginning of this rung. So let's go ahead and operate signal colon equals 0. So the first thing I want to do whenever I get here is I want to make sure that all of my transitions are turned off. And let's go ahead and do that for alarm signal 1 and offline signal 1 as well. We've got our operate signal is 0. Our alarm signal is going to be set equal to 0. And let's go ahead and call that a bool because it wasn't already defined. Let's jump out of here, and we're going to take our offline signal as well, pop back in, and that's going to be equal to 0 semicolon. And okay, so now we've got our 3 transitions being set equal to 0, but we're going to conditionally be setting one of those equal to 1. It's just a matter of which one we set first. Well, the first thing that we want to do is let's go ahead and define some things that are actually going to tell us that we're in good shape or not. So the first thing we want to look at is level. So how do we want to do that? Let's go ahead and copy this whole if block out right here, because that's already looking at level. And I'm going to just paste that right here in the middle. If level is less than, and we actually don't need it to be between 50 and 60. I just put that in there for control, but we actually really need it to be between 40 and 70. So if our level is greater than 40, and we're going to say the same thing. So let's just go ahead and copy that from there. I'm pretty lazy when it comes to typing. And it is less than 70, and I don't really need a space there, so let's just say less than 70. Then we're going to go ahead and set something called level underscore good, and we're going to set that equal to 1. Semicolon out of there, and yes, we want that to be a bool. And then we're going to have just not an else if, but we're just going to have a simple else, and then we're going to set that equal to 0. So let's just grab this whole thing, copy, paste it right over both of those lines, and set that to 0. So now we've got something telling us if our level is good, and we can go ahead and do the same thing and get something that'll tell us if our temperature is good. So now that we're controlling temperature, actually we don't really need to figure out if our temperature is good. We just need to know if our mixer is running, right? That's really all we need to have. So let's come down here and let's create something that is going to time and tell us that our mixer has actually been running for 30 seconds. That's going to be our second and only other condition to going into operation. So let's say if, and then we're going to look at our PLC program dot mixer and see if our mixer is running. Then, and now we're going to come down here and let's set up a timer. So I'm going to go ahead and create the end if real quickly just so I can put the call for the timer here. And I'm going to call this mixer underscore run time. That should be good. And semicolon that, and this is going to be a TON. And I want to call that mixer runtime timer every single scan after I update its values in here. So before I do that, I'm going to go ahead and set some stuff. I'm going to go ahead and set that preset. So mixer runtime dot PT colon equals, and that's going to be my T pound, and this is going to be a 30-second timer. So T pound 30 second. And I'm going to set that outside of any kind of if statement. So I want that to just always be set. And since that's kind of an initialization value, I'm just going to put that right up here on the top. So now it's not in the middle of all of our logic. So if the mixer is running, then I want to energize the timer. Otherwise, I want to de-energize the timer. So mixer runtime dot, and this is going to be dot, and this is going to be IN colon equals 1 semicolon, and then we want an else, and if that's not the case, then we're going to disable that timer. So otherwise the input is 0. Alright, and now we're going to update that timer at the end of this end block, and that needs to go right there. And the last thing we want to do is actually set the condition, make it true if that timer has actually timed out. So now we can come down here and we can start creating the conditions for our operate signal to be made 1. So let's come over here and say if, and that's going to be level good, and let's try and find that level good, and then we also want to look at our mixer timer. So mixer runtime dot Q, which means this thing has hit 30 seconds. Then and only then do we want to go ahead and hit our operate signal, and that's all we really need in this condition, end if. So from there we need to also check at setting our other couple of modes up here. And for the offline signal, it's really a quick and easy one to set that. So let's come down here, and I'm just going to paste that right there and make it equal to 1. And actually I've got a dash there instead of an equal sign. That's going to be a bug later on, so why don't I just go ahead and make sure to fix that now that I found it. Good. And actually, let's make that colon equals 0. Alright, that's what it's supposed to look like. So now we can come down here and we can go ahead and find our logic for this, and all that logic is going to be is if somebody pushed the stop push button. And I don't think we've created a stop and start button for the system yet. So let's go ahead and come down here and create a system underscore start underscore PB, and that's going to be a bool, and then we need a system underscore stop underscore PB, and that is also going to be a bool. Okay, so now we have a way to turn this thing on and off. Let's go back into our mode control and then back into our startup routine. And here we go. If, and that's going to tie back to our PLC program dot system start, and that's not what we want. We want system stop push button. Then we're just going to immediately transition into offline and end underscore if semicolon. Okay, so now we have a way to transition out, and we also have enough stuff going on inside of this routine that I believe it's now doing everything it needs to do. It's going to try to establish our level, it's going to try to establish our temperature, turn the mixer on, and I think there's one more problem that we might potentially have. And let's come up here and look at our level, and if our level is lower than 50, then we're starting the pump. That's good. But one more thing, we also need to make sure that our level is not greater than 70. So I think we also need some valve control in here. And that's the one thing I think we might be missing. So what if our level is greater than 70? And in that case, we're going to go ahead and call not pump start, but valve underscore open. We're going to set that to 1. Otherwise, we will come down here and set the same thing. So instead of pump stop, it'll be valve close. And we'll set that equal to 1. And likewise, we're going to also have to manage valve close here. And then we're going to have to manage valve open here. Okay, so we're either going to open our valve if we're above 70, and then we will close our valve, and let's go ahead and do that anytime we're less than 60. So we are going to fill up as high as 60, and actually I'm going to go ahead and tighten that control a little bit, and I'm going to say less than 65. So we're going to just get ourselves just down below the full level, and that's where we'll go ahead and close our valve. Okay, so now we have level control in both directions. We have heater control in one direction, but we don't need anything to, we don't have a high level for this right now. We just need to make sure that we're above 300 degrees. But we do still have one issue, and that is, what about going into our alarm mode? What about going into stability mode? And that's going to require that we take a break, and when we come back, we're going to have to set up our logic for our alarms. And since that's something general, that's going to be something that goes, into multiple different routines. We don't want to necessarily set that up inside one of our steps like we're working here. We can come back in here and, we can set a separate routine for alarms. So let's right click over here, add an object, and why don't we do this in a CFC? Those are pretty easy. We will call that alarms, and then we'll come right back over here to our main program, and let's go ahead and put in a call for that routine. Alarms, perfect. And here we go. When we come back, we will define our 3 alarms for this system and set up the logic in here. So, see you in the next.